Okay, let's do this. Example 5, from the chemical reaction data, there is a clear-cut. X is the clear-cut independent or control variable. Now, what do I mean? As long as you have a clear-cut independent variable, what do you immediately do? You go to your GC, you sketch the regression line of y on x, because this is independent. Then after that, regardless whether you are given x, estimate y, that means you given a value of x, estimate y, you use this line, or you are given y, estimate x. Whichever one you do, you still use the same line. That's what I mean. Follow what I'm saying? So let's discuss how to do it. Okay. In this case, x is the independent variable. So we will definitely use the regression line of y on x. This on x would mean that this, okay, you all know y on x. Okay. How do we do it? Okay, you can use your GC, you follow these keystrokes here, enter into L1, L2. Now, I want to emphasize that sorry. There are two functions here that do the same thing. You have number 4, linear regression a plus x plus b. That means a now is the gradient. Linear regression a plus bx, b is the gradient. It didn't matter which one you choose. Just do it and read off correctly. Follow what I'm saying? Okay? It didn't matter. Okay? You choose the right one and just read properly. So in my case, what I did was I chose number 4, all right? And x list must be the one on the horizontal axis. That means this must be the independent variable. You are going to regress y on x here, correct? Then you will get 1.8 and 1.6. In my case, my gradient is a is 1.8. If you choose number 8, you will get b equals 1.8, where b is what is the gradient. It didn't matter. Correct? It didn't matter. So, the regression line is y equals to, look here, 1.8x plus 1.6. Correct? Yes? So, just from the GC will give us this. So, in order to estimate a particular value of y given x, you use the regression line y equals to 1.8 times 3.5 plus 1.6. You will get a value 7.9. Now you are given y, you need to estimate what is x. It's this kind of case, you know. That means given y, what is this value x? Correct? But because x is the independent variable, you will still use the same regression line. Same regression line. You will say, oh, when y is 7, what is? Correct? Then you just rearrange, you will get x equals to 3. Alright, next part. Interpret the slope and the y-intercept of the regression line in the context of the question. Now, when you have a regression line like that, this is your line, y equals to 1.8x plus 1.6. This is y, this is x. Actually, it's not that difficult. The slope suggests that for every increase of 1 minute, Correct? Your X increased by 1 minute, your Y increased by 1.8 grams. Follow? In the context of the problem, I must conclude in the context, okay? Yeah, in the context of the problem. So for every increase of 1 minute, you expect an average increase of 1.8 gram of chemical produced. That's essentially it. Correct? So you conclude in context. For every increase of 1 minute, we expect an average increase. Keywords here, actually, we don't know. We only roughly expect an average increase. We don't know. We just roughly expect an average increase. Just from the regression line. That's answering the, what is the slope, correct? Interpret the slope. This is interpretation of the slope. What about the interpretation of the y-intercept? Y-intercept is here, right? 1.6, the y-intercept, right? This is the y-intercept. What does it mean? That means when x is 0, when time is 0, amount of chemical is 1.6. Correct? Yes? Science students, no problem. Which means that at the start of the experiment, there you expect to see 1.6 grams of chemical. Follow? Right? At the start of the experiment, that means x equals to 0, you expect to see 1.6.